Hello there, Algebra 1 peeps. We are at the beginning of a new chapter, Chapter 3, which is basically covering linear equations, linear functions. And our first lesson today is graphing linear equations that are in specifically what we call standard form. And standard form is basically when a function is in this form. A couple things I want to say about standard form. The variables, the x and the y in this case, both have an exponent of 1, x to the 1 power, y to the 1 power. You can't have x squared, y cubed. It has to be x to the 1 power, y to the 1 power. A couple of other characteristics that are specific to standard form. To be linear, you have to have x to the 1 power, y to the 1 power. So let me just clarify that. To be linear, you have to have x to the 1 power, y to the 1 power. But to be in standard form, not only do you have to be linear, but you have these three things that happen. So I want to just talk a little bit about that. The first thing that has to happen is that the a, and a is a coefficient. It's the number in front of x. A has to be bigger than or equal to 0. And then the second one is that a and b cannot both be 0. So although a can equal 0 and b can equal 0, you can't have them both be 0 at the same time. And then the last thing is that a, b, and c, so the coefficients of x and y, and the c, which by the way we call the constant term, the c, they're all integers. So I think you guys know what integers are. It has to be a negative or positive integer, can't be a fraction, can't be a decimal, and specifically with a greatest common factor of 1. Okay, so for example, here we have two examples of something that would be in standard form. Here the a value is 3, the b value is 2, and the c value is 5. So a is bigger than or equal to 0. A and b are not 0. And a, b, and c are all integers. There's no fractions, no decimals. And 3, 2, and 5 don't have any common factors. Okay, so that means that it satisfies all those conditions and we're good to go. And then we have x equals -7. And this might look to you like it's not in standard form. But remember that a, if it's not present, sorry, that's not what I wanted to do. A, in this case, is equal to 1 because the number in front of x is a 1x. So a equals 1. B is 0 because there is no y term. Okay, there's no y term in this equation. And then c equals -7. So again, a is bigger than 0. A and b are not both 0. One of them is 0, but they're not both 0. And then of course, a, b, and c, all these three numbers together have no factors, no common factors. So we're good to go. So even though it doesn't have both x and y in it, it can still be considered standard form. So the first example that we have is to determine whether each equation is a linear equation or not. And again, we said that in order for that to happen, your x and your y have to have x to the 1 power. So here in this case, the answer is yes. Okay, because you have y to the 1 power, x to the 1 power, and this is a variable term, that's a variable term, and here's your constant term. And it's not in standard form. And that second part is write the equation in standard form. In order for it to be in standard form, the x's and the y's should be on the same side. So we want to add the 3x to the other side, and then we're going to get 3x plus y equals 4. And now we have it in ax plus by equals c. Specifically, we know that a equals 3, b equals 1, and c equals 4. So a again is greater than 0. A and b are not both 0. And a, b, and c have no common factors, so this is now in standard form. So our solution is right here, standard form. Okay, so now you want to move on to part B. He's in his room. We want to go to part B. And this guy is actually, if you were thinking that it's a yes, it's actually a no. And I will explain why. Yes, you have x to the 1 power, x to the 1 power, y to the 1 power. But herein lies the problem. That you have the product of x and y. You can't have two variables in the same term. So can't have two variables in the same term. So the problem is not that you have x and y, because it's okay, not when you have x and y as well, but they're not in the same term. So this is the same term, so you can't have both of those in the same term. So this is a big fat no. So now we're going to give you a chance to do A and B here, do it yourself number 1, and we're going to move on to x and y intercepts. Eventually the section is asking us to graph, but we want to start off slowly here. And the first thing we want to do is talk about intercepts. And intercepts are exactly what they sound like they are. An intercept, an x-intercept and a y-intercept is the place where the line, when you graph it, it's the place where the line crosses or intersects the x and y axes. So, for the x-intercept, I'm going to give you guys a little bit of info here. For the x-intercept, the y-coordinate is always 0. You cannot be the x-intercept without the y-coordinate equaling 0. Okay? And likewise, the y-intercept, in order for you to be the y-intercept, the x-coordinate is always 0. Okay, so anytime, so here we have our y-axis. So for our y-intercept, we want to know, where does the line cross the y-axis? It's crossing right here. And if we were to ask what the x and y coordinate of that point are, the x coordinate, because you always start at the origin, and you're not going to move left or right. You're just smack in the middle. So that's why the x coordinate is 0. And then the y coordinate is 10, 20, 30. So the y-intercept is 0, 30. And even though the book doesn't necessarily teach it that way, I want to be very specific that when you write down the x-intercept or the y-intercept, you are required to write it like this in an ordered pair, where the x-coordinate is 0, and then you put the y-coordinate here. Do not tell me that the y-intercept is y equals 30, which is what the book is telling you to do. Do not put y equals 30. I actually want you to put the ordered pair 0, 30, because I want you to be aware that the y-intercept is a point. It's an ordered pair. It has an x-coordinate and a y-coordinate, okay? And then for the x-intercept, same question kind of, is where does the line cross the x-axis? This is the x-axis. It's labeled x. And so this is where it crosses the x-axis. And again, if I was trying to find the coordinates of that point, then the x would go first. I'd start at the origin, and I'd go 5, 10, 15, 20. So the x-coordinate would be 20. But then as far as the y-coordinate, I wouldn't go up or down. I would just stay there. And that's why the y-coordinate is 0. Okay, so again, in order to be the x-intercept, the y-coordinate is always 0. In order to be the y-intercept, the x-coordinate is always 0. And that is how you find the x and y intercepts of the line. So now we're going to have you find the x and y intercepts of this graph. And then we're going to move on to how to find the x and y intercepts from a table. Okay, so should be really easy based on what I told you in the previous example. But let's read the problem. A swimming pool is being drained at a rate of 720 gallons per hour. The table shows the function relating the volume of water in a pool and the time and hours the pool has been draining. So it makes sense to us that when x is 0, that's when time is beginning. Okay, when x is 0, the pool has 10,080 gallons of water in it. So it would make sense to us that as hours progress, 14 hours later, then the pool has 0 gallons of water in it. So along the way, you see that it starts at 10,080 and it's decreasing every single time because water is being drained out of it. So how to find the x-intercepts of the function should be fairly simple, because we know that for the x-intercept, we are looking for a point where the y-coordinate is 0. So all we have to do is come to our table and look in the y column, and where does it have a y-coordinate of 0? Right here. So this little guy is going to be our x-intercept. So we're going to get 14, 0. Then we have our y-intercept. And for our y-intercept, we said before that in order to have the y-intercept, the x-coordinate should be 0. So now we go back to our table and we're looking at our table and looking for the place where the x coordinate is 0, which is right here. So this little guy is going to be our y-intercept, and the x coordinate is 0 and the y coordinate is 10,080. Alrighty, so that's our x-intercept and our y-intercept. And then in part B, it asks us to describe what this means for the situation. So, like I said earlier, it means that the y-intercept is the easiest start. It means that at the beginning of the day, when you hadn't started draining, so there's no hours have passed yet, then you had 10,080 gallons of water in the pool. And then 14 hours later, the pool is completely drained because there are 0 gallons of water in the pool. So that is how you would describe what the intercepts mean in this particular situation. So we want you to try do it yourself number 3. And then we're going to get to the heart of what the lesson is about. And that is graphing. Okay? So this equation is in standard form, ax plus by equals c. And we're going to use the x and y intercepts to graph. So this time, instead of looking at a table, we're going to find the x and y intercepts from the graph. But again, it's all going to be based on what we said earlier about the x-intercept and the y-intercept. For the x-intercept, you have to make y equals 0. Because we know that the y-coordinate of the x-intercept, going back over here, we know that the y-coordinate, the y-coordinate of the x-intercept is always 0, and we know that the x-coordinate of the y-intercept is always 0. So that tells us that for the y-intercept, we are going to make x equals 0. So it's kind of easy to remember. For the x-intercept, you make the opposite letter 0. So for the x-intercept, y equals 0. For the y-intercept, x equals 0. And then you just solve. So we're going to say 2x plus 4 times y equals 16. And over here we're going to say 2x plus 4y equals 16. Notice that I left the y spot open because I'm going to make y equals 0. And in this case, I left the x spot open because I'm going to make x equals 0. Okay, now what's going to happen here is that because 0 times anything is 0, this entire term is going to disappear. Okay, and so all we're going to be left with is 2x equals 16. And then we're going to divide by 2, and x will equal 8. So the x-intercept for this graph is x is 8, y is 0. Okay? But I want to show you that there's actually kind of a shortcut here. This is the way to do it the long way. But you will notice that it doesn't matter what you do. If you plug in a 0 for the y-coordinate, then this term will always disappear because 0 times anything is going to be 0. In other words, what I'm trying to tell you is that if you had ax plus b times 0 equals c, it wouldn't matter what b is. 0 times anything is going to be 0. So what we call this is hide. If you hide this term, then all that's left is ax and c, like we had here, ax and c. And then you divide. So the shortcut that we call this is hide and divide. It provides for a fast way for you to find the intercepts. Hide and divide. So you hide the term and then divide by 2. So if you don't like the shortcut, it's okay. You can do it the long way. But I just wanted to make sure that I showed you the shortcut. So now we're going to continue here. Again, going with the hide and divide concept. When I make x equals 0, then this term is going to go away because 0 times anything is 0. So I'm going to hide that. And what's going to be left is 4y equals 16. And then to solve 4y equals 16, I divide by 4. So again, you see that two-step process. Hide this term, divide by 4. Or by whatever's in front of the variable. 16 divided by 4 is 4. So now my y-intercept is x is 0, y is 4. Okay? So now I can plot those points on my graph. So 8, 0 is going to be, again, we start at the origin, and we start with the x first, 2, 4, 6, 8, and then you don't go up or down, so there's 8, 0. And then we're going to do 0, 4. So that's, again, starting at the origin, and then x, you don't go anywhere left or right, but you do go 4 up, 2, 4. Put my point there. And then we connect the 2 points, and bam, just like that, we have we have our line, okay? So to generalize what we said about the ax plus by plus c, I can give you a formula. For the x-intercept, okay, you're going to get, let's see here, this is ax plus by equals c, so it's going to be c divided by a, comma 0. And over here, for the y-intercept, to summarize, using the a, b, and c, we're going to get 0 and c divided by b. Okay, and again, this is based on ax plus by equals c. I don't want to confuse anybody. But if I make y 0, then I'm going to hide the b, and I'm going to get ax equals c. So to solve for x, I'm going to divide by a, so hence c divided by a. That's going to be my x coordinate, c divided by a. In the case of the y-intercept, I'm going to cover the x with a 0, so that's going to be hidden, and I'm going to get by equals c. Then I'm going to divide by b to get y by itself, and it's going to get c over b for the y coordinate. So just if you don't, if you want to use a formula, then that's a formula that you can use. So you can now try these two, and then we're going to go to our last example, and that is to graph using a table. All right, so this is not standard form, so we can't really use x and y intercepts, but we can make a table of values. And I want to be very clear here, because when I'm in class, sometimes people ask me, where did you get that x from? Where did you get that x from? X is what we call the independent variable. And when you're independent, that's when you don't have to ask for permission for anything, like from your parents, for example. Most students, if I asked you if you were independent or dependent, you would probably say independent. You would probably say dependent, because you depend on your parents for everything. You depend on them for food, for clothes, for money, for permission to go places. But if you're independent, like your parents, for example, they don't have to ask you if they can go somewhere. So they're independent. So when you're independent, you don't have to ask for permission to do anything. So again, when the x coordinate is independent, so we don't have to ask for the x. I can pick any number I want. Any number I want, okay? But you cannot pick any y you want. Y depends on what x is. So once we choose x, arbitrarily, randomly if you will, then you have to plug x into the equation to get the y coordinate, okay? So now I'm going to show you how to do that. So I am going to be strategic about what I pick, because I see a fraction here, 1/3 times x, and I don't want to pick numbers that are not going to divide evenly. So for example, I'm going to pick numbers that multiply by 1/3 evenly and not have fractions, okay? I'm also going to pick 0, because it's always good to pick negative numbers, 0, and positive numbers. I'm going to pick 3. I'm going to pick 6. And really, after you have 3 or 4 points, you don't have to have more than that. So what do I mean by, so first of all, I can randomly, if you're asking how did I pick those numbers, I can randomly pick whatever I want. I specifically chose 3s, multiples of 3, because it's 1/3 times something. So now, how do I get the y value? You can't just pick the y value. You have to plug it back in. So that means that y is going to equal 1/3 times x plus 2. And so what's going to happen is that since I chose x to be -3, I'm going to replace -3 here, and then I'm going to get an answer. So 1/3 times -3 is -1, and then plus 2, 2 minus 1 is 1. So the y value is 1. I do this several times. As many times as I have points. So I have it 4 times. So now I'm going to pick 0. So 1/3 times 0 is 0 plus 2, which is 2. And then I'm going to go y equals 1/3 times x plus 2. And this time, I'm going to replace x with 3. So 1/3 times 3 is 1, and 1 plus 2 is 3. And the last number I'm going to pick is 6. So 1/3 times 6, which is 2, because 6 divided by 3 is 2, plus 2, and I get 4. And so now I've completed my table, and that's great. And so now all we have to do is plot those points over here. So I'm going to look for, here, starting at the origin, negative 3, 1 is going to be negative 1, negative 2, negative 3 for the x, and positive 1 for the y, and there's my point. Then I'm going to go to the next one, 0, 2. Here's x equals 0, 1, 2. My next point is 3, 3. So here's 0. I'm going to go 1, 2, 3, and then 1, 2, 3. Put my point. And the last one's going to be starting at 0 and go all the way to 6, and then up to 4, which is right about here. There's 4, there's 6. Try to get it as good as you can there, okay? And then you just connect all your little dots with a line. And that's how you graph using a table. So remember again, you can pick any x values you'd like, but you have to plug the x values into the original equation to determine the y values, and then you can plot your ordered pairs and draw a line through your ordered pairs. Okay? So you have this last example to do for yourself, and once you've done that, you will have completed the notes for this lesson, and I will see you in class, and I thank you for watching.